Cooking looks simple, but heat changes food in surprising ways. It melts, hardens, softens, expands, and sometimes completely transforms what we started with. These changes aren't accidents. Heat affects molecules, pressure affects structure, and time affects texture and flavor. In this video, we're looking at what really happens when food meets heat, why cakes puff up, why popcorn pops, why chocolate melts, and why some foods behave differently than we expect. Once you understand how heat works, the kitchen starts to look less like guesswork and more like a quiet science lab we use every day. When cake batter goes into the oven, heat immediately starts changing what's inside it. Ingredients like baking powder or baking soda release carbon dioxide gas as they warm up. At the same time, air that was mixed into the batter during stirring begins to expand. These gases form tiny bubbles that get trapped in the thick batter. As the bubbles grow, they push the batter upward, causing the cake to rise. While this is happening, heat also firms up the proteins and starches in the batter. If everything happens in the right order, the structure sets while the cake is fully expanded. That's what allows the cake to stay tall instead of collapsing. So cakes puff up because heat creates gas, and careful timing locks that structure into place. Each popcorn kernel contains a small amount of water trapped inside a hard outer shell. This shell is strong enough to hold pressure, but only up to a certain point. When the kernel is heated, the water inside turns into steam. As the steam expands, pressure builds inside the shell. The temperature continues rising until the shell can no longer contain that pressure. At that moment, the shell bursts open. The inside of the kernel rapidly expands, flips inside out, and cools almost instantly. This sudden expansion is what creates the fluffy popcorn shape. So popcorn pops because heat turns water into steam, and trapped pressure forces the kernel to explode open. Once the shell breaks, the steam escapes immediately, freezing the popcorn in its expanded form. Chili peppers feel spicy because they contain a chemical called capsaicin. Capsaicin doesn't burn your mouth physically, but it interacts with nerves that normally respond to heat and pain. When these nerves are activated, they send signals to the brain that feel like burning. The brain reacts as if the mouth is exposed to heat, even though the temperature hasn't actually changed. This response is part of the nervous system's warning system. It's designed to detect potential danger, not flavor. That's why spicy food can cause sweating, tearing, or a racing heartbeat. So spiciness isn't a taste like sweet or salty. It's a pain signal created when capsaicin triggers heat-sensitive nerves. Milk can reduce this sensation because its fats bind to capsaicin and help remove it from the nerves. Ice cream headaches happen when something very cold touches the roof of your mouth. This area contains blood vessels that react quickly to temperature changes. When exposed to cold, these blood vessels constrict and then rapidly expand. This sudden movement triggers pain signals that travel to the brain, creating the sensation of a headache. Although the pain feels like it's coming from the head, the reaction actually starts in the mouth. The discomfort usually fades once the temperature in the area returns to normal. So ice cream headaches aren't dangerous or harmful. They're a temporary nerve response caused by sudden cold exposure. Eating cold foods slowly gives blood vessels time to adjust and can reduce the chance of discomfort. Jell-O jiggles because of how gelatin behaves when mixed with water. Gelatin forms a flexible network as it cools, creating a loose structure that holds liquid in place. The water trapped inside this network can move slightly when the dessert is shaken or touched. Because the structure is flexible rather than rigid, it bends and shifts instead of breaking apart. This movement is what creates the familiar wobbling motion. The dessert isn't liquid, but it isn't fully solid either. So Jell-O jiggles because its structure allows motion while still holding everything together. That balance between firmness and flexibility is what gives gelatin desserts their unique texture. When you cut an onion, its cells break open and release chemicals into the air. These chemicals quickly react with moisture, including the moisture in your eyes. The reaction forms an irritating substance that triggers the eyes to produce tears. Tearing is a protective response designed to flush the irritant away and protect the surface of the eye. The more damaged the onion cells are, the more of this chemical is released. That's why cutting onions can feel worse than slicing them carefully. So onions make us cry because the eyes are defending themselves from chemical irritation, not because of emotion. Reducing how much of the chemical reaches the eyes can lessen tearing, which is why techniques like chilling onions sometimes help. Chocolate melts easily because it contains cocoa butter, a type of fat with a relatively low melting point. This fat is solid at room temperature but begins to soften quickly as it warms. When chocolate heats up, the structure of the cocoa butter breaks down, allowing the chocolate to shift from solid to liquid. This can happen in your hand, your mouth, or even in a warm room. This property isn't accidental. Cocoa butter is structured to melt close to body temperature, which gives chocolate its smooth, creamy feel when eaten. So chocolate melts not because it's fragile, but because its fats are designed to soften with gentle warmth. That low melting point is also why chocolate must be stored carefully to keep its texture stable. Food doesn't just taste good, it follows science. Every pop, melt, rise, and sizzle is the result of heat and pressure working on ingredients in predictable ways. The same rules apply whether you're baking a cake, boiling water, or heating leftovers. Change the temperature and you change the outcome. Understanding this doesn't take the joy out of cooking. It often makes it more satisfying because you can see why things happen instead of just hoping they do. Once you notice how heat shapes food, you'll start seeing science at work every time you step into the kitchen.